To differentiate a product when two terms are multiplied together, say if one term is u and one term is v, then this is the product rule. And what that says is we get the first term and multiply it by the derivative of the second term. We get the second term, leave that alone, and multiply it by the derivative of the first term. So it's the first term, then multiplied by, put a little dot for multiply, d by dx, the derivative of second, plus the second multiplied by the derivative of the first. So let's have a look at that by doing a little example. So let's just use the one we did before, x to the 6 multiplied by x to the power 3. So that was x6 x3. So dy by dx. So the first, leave that as it is, then the second term, which is x to the 3, plus the second term, which was x to the 3, and d by dx, the first term, which was x to the 6. And when we work that out, that's x to the 6 differentiating 3x, we get 3x to the power 2 plus x to the power 3, and when we differentiate 6x to the 6 rather, it's 6x to the power 5. That becomes 3x to the power 8 plus 6x to the power 8, and we have 9x to the power 8, and that is your answer. Okay, let's go over some examples of using the product rules. So here we have a product. So this is this function times this function here, so two functions. So y is x to the 2/3 multiplied by 3x minus x to the 2. So y prime that becomes, leave the first term alone, x to the 2/3, and then we get the differential of the second term, which is 3 minus 2x, plus, leave the second term alone, which was 3x minus x squared, and then multiply that by differentiating the first term, which is, bring 2/3 down, x 2/3 minus 1 minus 1/3. So this then tidied up, y prime becomes x to the 2/3. Try and put the x's first if you can. Any x's and powers in order from the highest power to the lowest power from left to right. So if we put the x first, we get minus 2x plus 3 plus, and when we tidy this up, we get 2 all over 3 cube root of x, and then minus x squared plus 3x. For the second one, y prime, first term, leave that alone. Differentiate the second term and we get minus 2 plus, leave the second term alone, so that's 10 minus 2x, and multiply that by differentiating the first term, and that becomes 2, bring the 2 down, that's 12, and x2 minus 1 is 1, and then for the minus x that stays as 1. Now multiply these two bracketed terms together and then multiply these out, so use our FOIL method. So y prime becomes minus 2 times minus 6 minus 12 x squared plus 2x minus 24x squared plus 122x minus 10, and when we tally that up, dy by dx is minus 36 squared plus 124x minus 10, and that is our answer. In this question, cos 2x, we have to use the chain rule because it's a function within a function. So let's start using the product rule on this. Dy by dx, so leave the first alone, x2 power 2 times dy by dx cos 2x plus, leave the second alone, cos 2x, and multiply that by differentiating the first, which was x squared. So how to differentiate cos 2x, we go back to the chain rule. So cos, let's just do this as a side, y equals cos u equals 2x. So when we differentiate we get minus 2 sine 2x. So let's put that back in here. So that becomes x squared minus 2 sine 2x plus cos 2x multiplied by 2x. When we multiply the brackets out and tidy up, this becomes, we can take a 2x out, and in the bracket we have minus x sine 2x plus cos 2x. On this next one, let's apply the product rule. So dy by dx, first term, leave that alone. Differentiate the second term, which is e to the 3x, plus second term multiplied by the first term. Okay, so that becomes 1 minus 3x. When we differentiate e to the 3x, we get 3e to the 3x. All add e to the 3x, and then when we differentiate this we get minus 3. So this, when we tidy up, becomes e to the 3x, 3 minus 9x minus 3. 3 minus 3 is 0, leaves us with minus 9x. So the answer is minus 9x e to the 3x. Okay, this is a pretty simple one. Let's just apply the rule. So y prime is the first term, x squared plus 7x minus 2, multiplied by the derivative of the second term, which is 4x plus 2, plus we get the second term by itself, which is 4x plus 2, and multiply that by the derivative of the first term, which was x squared plus 7x minus 2. So this then becomes x squared plus 7x minus 2 multiplied by 4 plus, I'll leave the plus where it is so we know where we are, 4x plus 2, the derivative of that, bring the 2 down, becomes 2x, and then when we get the derivative of 7x, we're left with 7. Minus 2 is a constant, so we'll leave that out. And then when we multiply out the brackets, we get 4x squared plus 28, 28x minus 8 plus 8x squared plus 28x plus 4x plus 14, and then when we add the like terms, that becomes 12x squared plus 60x plus 6, and that is the answer. This one is slightly more complicated, but just apply the rules and go step by step and you should be fine. So let's start on this. So y prime is first term x minus 2 dy, or d by dx rather. Second term 5 plus 3x to the minus 3 plus second term multiplied by the derivative of the first term. This then becomes x to the minus 2. When we do the derivative of this term, we get minus 9x to the minus 4 plus, leave the first term alone, and the derivative of x to the minus 2, bring the minus 2 down, x minus 2 minus 1 becomes minus 3. This, then when we multiply out the brackets, that becomes minus 9x to the minus 6, minus 10x to the minus 3, minus 6x to the minus 6, which is 15x minus 15x to the minus 6 minus 10x to the minus 3. Right, you can, that is the answer. If you want to tidy that up, we can bring the minus 6 down, so that becomes minus 15x over 6 minus 10x over 3. Then we get a common denominator, and then when we do the subtraction with a common denominator of x to the 6th, we get minus 15 plus 10 x3 all over x to the 6th. Right, let's do the product rule with a logarithm and then with a sine function. Again, just follow the rules of the product rule. So let's go dy by dx equals first term differentiate by the second term, which is the natural log of x, plus the first term, and then we multiply that by the derivative d by dx of x to the 4. When we do that, we get x to the 4, and then natural log of x is 1 over x plus natural log of x, and then when we differentiate x to the power 4, we get 4x to the power 3. When we tidy that up, it becomes x power 3 plus 4x with 1x. And then tidying that up, we bring the x to the power 3 to the outside, we get 1 plus 4 1x, and that is our answer. And this one, again, let's just do f prime of x. First term, 3 to the power 2. Then the derivative of tan x, sec squared x, plus second term, tan x, multiplied by derivative of the first term, and that becomes, bring the 3 over 2 down, 6 x, and then 3 over 2 minus 1 is a half. Tidying that up, we get 6x 3 over 2 sec squared x plus 9x to the power half tan x. Taking the 3x to the power half out as a common factor, get 2x sec squared x plus 3 tan x, and that is our answer. Okay, this one confuses a lot of people because it's got e to the x in it, but just remember, when we differentiate e to the x, we just get back e to the x. So let's get g prime of x. First term, leave that alone. Then we're going to get the derivative of the second term, which is 8 minus square root of x, plus the first term, leave that alone, use the second term, which is 8 minus square root of x, multiplied by the derivative of the first term, which was e to the x. Working this out, we get e to the x, derivative of 8 minus square root of x becomes minus a half x minus a half, plus 8 minus square root of x, And then when we get the derivative of e to the x, that's just e to the x. Rearranging, we get minus e to the x all over 2x to the power half plus 8e to the x minus square root of x.